This is a fungus, but it's more than that. It's also a pathogen of soybeans. It's the off season now for this fungus, but it's gonna grow and a mushroom's gonna come right out of the top of this, which is gonna spread spores. Many of these spores are ultimately gonna infect soybean plants, and many of those plants are gonna die from this pathogen. And that's gonna cost farmers a lot of money. To manage this disease, what you would do is apply a fungicide that's gonna kill some of those spores or prevent them from germinating and killing those plants. And farmers spend millions of dollars trying to manage this, but it's not always effective. And one of the big reasons for that is we don't know exactly the optimal time to manage for this every year. In attempts to control this disease, a lot of that chemical is put out with inaccurate timing. It's just not perfect. It might be too early or too late, but it's not really going to protect those plants from this disease. The way farmers manage this now is just through personal experience. You know, they know when they've had this disease in the past and they know what's worked for them then, but it's not always going to be most effective or the same every year. That infection window for the disease is highly variable. It might come early one season, it might come late next season, and a lot of times it doesn't come at all. You might have years with no disease, but because of that past experience, you might have that urge to go out and make an application for this. Any of those situations where that chemical is not put on at the correct time, it's not going to be cost effective. Another method used for timing that fungicide application could be observing symptom development in the field. We often call these rescue treatments, but research has shown that those are rarely effective at making any difference. And the reason that is because those plants were infected a couple weeks earlier, and you're just seeing that symptom development as it's killing those plants from the inside out and finally showing up on the outside. So by that point, it really doesn't make sense to protect those plants. The chemical's not going to get in, and it's not going to save those plants. Another potential method to time that fungicide application is scouting. If you go out and you see these sclerotia growing small mushrooms out of the top, you'll know it's time to apply that. But you could imagine how small that mushroom's going to be based on how big this is. You know, at most as big as the tip of your pinky, and the timing is when those plants are starting to canopy out, which makes it even more difficult to get down there and see that. So scouting is really not an effective option. So what our goal is at sites like this one is to identify when these mushrooms grow with local weather patterns and different conditions here across the state of Nebraska. This is a base weather station where we're collecting rainfall data, humidity, solar irradiance, we're collecting temperature. We also have sensors on here looking at humidity and temperature down low. Now, why the difference? Why the redundancy? Well, one of the big reasons is because as these plants grow, they're small now, but they're going to grow up and that canopy is going to be above this. And what we expect to see is divergence between the humidity at the high level and the humidity at the lower level. It's probably going to be more humid down here under the canopy. We also have a leaf wetness sensor. That's going to be another representative trait of what sort of moisture we have on the leaves that's going to allow those spores to grow. Another set of sensors over here are light sensors. We've got two of these. One is in the row, one is between the two rows. That might just help us calculate how the canopy is closing and when that canopy is closing. Because when that canopy closes off, it's really making a roof over this entire 2.5, 3 feet to the ground. That's going to keep the soil surface wet. It's going to keep the leaves wet longer, and that's what's going to drive that infection. Now, the last thing we have here is a time-lapse camera, and what it's pointing at is a collection of sclerotia. Those sclerotia fell to the ground, and now they're laying on the surface. We're going to watch those develop, and that's the key to this whole thing. That's going to show us exactly when that timing is triggered for that development, and we're going to be able to use this data, along with several other stations of this throughout the state, to help identify predictors that could help us time those fungicide applications. If we can time those applications better, we can save growers tens of thousands, hundreds of thousands of dollars. We could also potentially prevent unnecessary fungicide applications. This research is funded by the Nebraska Soybean Board, and the purpose of it is to save growers money and increase on-farm profit here in Nebraska. If you have more questions about soybean white mold, go online to cropwatch.unl.edu.